Well, hello everyone. We chose with Melissa for our topic these ozone depleting substances. Halogen source gases, mostly with chlorine and bromine chemicals, have long lifetimes in the atmosphere. Combined with the properties of ozone depletion are the main factors that build up all the high risks of these substances. I would also think that explains why the classification of these compounds have taken advantage of the values of two different variables, that ODP value and that GVP value. I collected all the related substances, sorting and grouping them into protocol-like lists from the handbook for the Montreal Protocol on the substances that deplete ozone layer. Here we have Annex A list of controlled substances that have two groups, and first one of these consists only CFC compounds and second one only halos. CFC molecules have formed with chemical elements of chlorine, fluorine and carbon. Halons are organohalogen compounds that contain one or two carbons bound by any but at least one of the halogen elements that are fluorine, chlorine, bromine or iodine. Here we have Annex B list of three separate groups, and first one consists only CFC compounds, but second and third group both have single compounds, which are also singled out in the Finnish government decision about ozone depleting substances. So group 2 has only carbon tetrachloride and group 3 has only 1.1.13 chloroethane, aka methylchloroform. Group 1 consists only from CFCs, so I'll skip those, but carbon tetrachloride, aka tetrachloromethane, is a natural compound as it's man-made. Tetrachloromethane has been produced as byproduct from chlorinization process of variety of low molecular weight hydrocarbons or by thermochlorination process of methylchloride. 1.1.13 chloroethane. Vapor of this compound is heavy and compared with air it's 4.6 times denser. It has quick and rather drastic reaction with air, so this substance will evaporate at the temperature of 20 Celsius degrees. The compound is harmful to aquatic organisms and it's carcinogenic for humans. Here we have substances from Annex C, HCFCs, HBFCs and bromochloromethane. HCFCs are mixtures of hydrogen, chlorine, fluorine and carbon. These were artificial substances developed as substitutes for CFCs until scientists found out that same capability of depleting ozone that those original CFCs have. HBFCs, most noticeable difference towards other ODSs is the high number of isomers that these substances have. Third group is that single substance, bromochloromethane, which is colorless liquid with sweet odor, with as a feature it is insoluble in water as it denser than water, what makes it to sink into the water and not to soluble into it. For this annex you can see only one group and with only single substance, which is methylbromide. As pesticide and in process of fumigation and sterilization of soil, this substance has wide functionality from weeds to different kind of rodents, and most of the living things between them, including humans, are going to feel the effects of this substance when exposed to it. Frankly, the compound has its own very drastic reactivity for vaporization, which is also the reason for majority of the usage of this substance, because the pesticides and soil sterilization processes from 50 to 95% of the methyl bromide eventually enters the atmosphere by evaporation from the soil and the pesticides. And here we have list of substances from the NXF with two separate groups which both consist of HFCs. HFCs are created as byproducts from different kind of chemical or manufacturing processes. And here we have a list of standard applications of these substances and all the most important sources as an ODSs. And there's many more besides these one. There's also a really new study from a couple of weeks ago from MIT researchers that have found out all of the oceans are holding down quite drastic amounts of that CFC11 substance, and those researchers estimated we should add 5 more years for the lingering times of CFC11 emissions in the future, to be precise with these estimates. The most important effect for environment happens for the ozone and ozone layers. In a reaction where 3 oxygen atoms merge, the gaseous molecule of ozone is formed. The Earth's ozone layer splits in the atmosphere into 2 of its layers, but most of the ozone molecules are located at the layer of stratosphere from the height of 15 kilometers until up to 50 kilometers. When we are playing with ozone depleting substances, we are also playing with most of the lives that live on Earth. From the point of the view life on Earth, the importance of the ozone molecules at the stratospheric layer is derived from their ability to filter out UV rays of particular types. The types of radiations that are actively filtered by the ozone layers are UVC, UVB and UVA. Nature has its own boosting effects for ozone depletion reactions from volcanoes and weather conditions.
Then we have global effects. The ozone layer protects life on Earth, as we all know. Decline in emissions of ozone depleting substances have big climate benefits. The most ODS are potent greenhouse gases. Phasing out these substances directly reduces greenhouse gas emissions. Atmospheric ozone effectively absorbs the sun's ultraviolet radiation and thus saves the biosphere from the harmful effects of ultraviolet radiation. And the UVB radiation directly affects both plant physically and development, and the phytoplankton levels have decreased due to the increased UV radiation in Antarctica. Environmental concentrations, use and emissions in history, present and future. Prior to the 18th, ozone depleting substances were pervasive in life. The work of individuals, businesses, organizations and governments around the world substitutes that are safer for the ozone layer continue to be developed for many ozone depleting substances. And data for 2019 show that the consumption of the ODS is the EU remained negative, which is really good. And it's meaning that more substances were destroyed or exported than we produced or imported. The EU's consumption of these substances have been negative since 2012. In 2019, the production of the new substances amounted to 1 million metric tons, an 11% decrease compared with 2018. All developed countries scheduled to complete their phase out the ODS in 2000 to 2030. And 2060 to 2075 is the earliest time frame project for the ozone layer to recover. Certain uses are still permitted, such as feedstock use, some laboratory and analytical use, and the firefighting technology to prevent. Companies all around the world invested in unprecedented research and development is still finding ways to eliminate the use of ODS. The fire protection sector played a key role in ODS to variety of similar substitutes and alternatives as fire protection agents. The use of many compounds have been reduced because suitable substitutes have been found for them. Owner of a refrigeration, air conditioning and heat pump and all kind of cold machines which is containing 3 kilograms or more of ODS must ensure that the equipment is inspected at regular intervals in accordance with the regulations. The inspection time depends on the amount of refrigerant. Police to prevent. In order to protect the ozone layer, the manufacturer use entire supply, import, and export of products that are developed of the ozone layer are largely prohibited. Restrictions corresponding to new reclaimed ODS that contain potential products. Ozone ODS must be treated as hazardous waste, and the restrictions are based on the Montreal Protocol, which is binding on all countries in the world. The EU has a regulation on substances that deplete the ozone layer, and also in this case the public impact of the Montreal Protocol has been far-reaching, and it's celebrated as one of the most successful international treaties ever implemented at an international scale. In an estimate by the US Environmental Protection Agency, the ozone layer would have collapsed by 2050 without the Montreal Protocol, and this picture also shows that the UV index measure would have increased dramatically. This could have led to an additional 2080 million estimated cases of skin cancer and 1.5 million skin cancer deaths and 45 million cataracts just only in the United States. Thank you.